Welcome to the Intel Graphics Performance Analyzer's DirectX workflow video. My name is Seth Schneider, and I'm a software engineer here at Intel. Today we'll be discovering how to use the different tools within GPA related to the DirectX workflow. If you're new to GPA, you can find an introductory video linked in the description below. Now let's do a quick review of the various tools offered within GPA. For online analysis, we have the HUD and System Analyzer. For offline analysis, we have Platform Analyzer for CPU-bound games and Frame Analyzer for GPU-bound games. The basic workflows change slightly depending on what platform you are targeting. Today we will be covering the Windows DirectX application workflow. In another video, we will be covering the OpenGLES workflow. Let's start with the DirectX tutorial. We're going to choose a DirectX workload and go through both live and offline analysis with it. So for the first thing we're going to want to do is we're going to want to open up Graphics Monitor. So right-click on Graphics Monitor and run it as administrator. This will make sure that we can capture all the proper metrics to help us determine whether we're CPU or GPU bottlenecked. When Graphics Monitor opens up, you'll see the IP address here in the bottom right-hand corner. This is helpful if you're connected to a remote machine, but in this tutorial today, we'll only be using this local machine. Once Graphics Monitor is started, you're going to want to right-click on it and then select Analyze Application. Once you've done that, this dialog will come up. It'll show you the available EXEs or applications that you can analyze. If you don't see your application here, you can click here and browse for the application you would like to analyze. Today, we're going to analyze City Racer. So let's open that program up. All right, once the program is opened, you'll see the HUD in the top left-hand corner here. We're running at about 30 frames per second. It gives us our DirectX hardware level and our resolution. If we maximize the screen, we'll see our resolution go to the appropriate resolution. We also have a couple control hotkeys here. So if we hit Control F1, it'll bring up the graphics metrics pane. So these panes are 4 different metrics that we are calculating real time. So you can change these in the Graphics Monitor profiles, but I've chosen these 4. So here we have target app CPU workload percentage, GPU percentage, or GPU busy percentage, GPU duration, and pixels rendered. We'll use these to help us determine whether we're GPU or CPU bound. If we hit Control F1 again, we'll see our control options. Here you'll see your basic HUD controls, and then right below you'll see your overrides. So the purpose of live analysis is to discover whether you are, in fact, GPU or CPU bound. These overrides can really help in determining that, especially one which is called disable draw calls. Now, when you disable draw calls, if your frame rate goes up, you're going to be mainly GPU bound. This is because most of the draw call work is done on the GPU, and so if you get a significant frame increase, you're probably bottlenecked on the GPU. So let's do that real quick. So if we hit Control, Alt, and N, our screen will go black because there's nothing to draw, but we'll notice that our frame rate increases drastically, over 2x. So we know we're probably GPU bottlenecked. So if we turn that back off, what then we will want to do is capture a frame. So we hit Control-Shift-C, we capture a frame. And then if we were CPU bottlenecked, we take a trace. So let's just do that now. Control-Shift-T will take a trace. It'll trace 5 seconds of data, capturing both the CPU and GPU cues. Now that we've captured both the frame and the trace, we're done with live analysis for now. Tune into one of our other videos, which will go more in depth about live analysis and go over each of these overrides. But for now, let's close the application, and we'll close this. And we'll continue to offline analysis. Now in offline analysis, we have primarily Frame Analyzer and Platform Analyzer. Frame Analyzer is for frames, Platform Analyzer for traces. So since we're GPU bound, let's open Frame Analyzer for DirectX. It'll open up here, and then we'll see all the possible frames that we've captured. It's sorted by date, so this is the one that we just captured together. So let's open it. You'll notice the progress bar in the bottom right hand corner. Once that finishes and all the render target thumbnails load, we can start analysis. So there it goes. Everything is loaded. We'll go over more details of this tool in a future video, but for now, the basics of this tool is to use the bar chart up here to determine which draw calls are most expensive. So by selecting the larger draw calls, we can see in the bottom right hand side what object that was, look at the details pane to discover more about the details of this specific draw call, such as where the EU is active, vertex shader, pixel shader information, basically anything you'd want to know about a specific draw call, this tool will provide. This helps you find out where certain draw calls can be optimized and exactly where you're spending time on the GPU per frame. So next, if we were CPU bound, we would be using Platform Analyzer. So all you'd have to do is double click Platform Analyzer, open it up, and you'll see something similar like what you saw in Frame Analyzer, but these are traces instead of frames. So it's sorted by date again. So the top one's going to be the trace we just took together. So let's open that up. It'll load, analyzing the entire trace we took. It's just going to take a second. All right. So the trace is loaded, and basically you'll see this large array of data. What I would recommend is pretty much going straight in, selecting a small window of data, and zooming into that selection. Now this is a little bit more digestible, but in here we can see basically our timings between our GPU and CPU frames, as well as how the GPU queue is populated. In the future we'll go over this application in more detail, but for now, for the purpose of the workload video, this would be where you'd go if you were CPU bound. Thank you for taking the time to learn about the DirectX workflow. If you have any questions, feel free to post them in our forums on the Intel Developer Zone, or check out our support pages at the link below. Also, be sure to check out our other GPA tutorials. Thank you for watching.